Hello everyone, my name is Sakib and I am super excited to be part of this year's Advent of Cyber by TryHackMe. Advent of Cyber brings you with amazing learning objectives daily from 1st December to 24th December, and each day we get a chance to learn something new and also get a chance to win amazing prizes. And at the end, once we complete all the tasks, we will also get the certificate. This year, we are covering different topics from machine learning, malware analysis, penetration testing, SOC, and digital forensics and incident response. Today, we are going to cover day 15 task, which is on machine learning. So and the title of today's task is Jingle Bell Spam Machine Learning Saves the Day. Before starting, I'll start the lab because it will take around 3 to 5 minutes to load. So let's give it some time to load and read the task out. Okay. So over the past few weeks, best festival company employees have been receiving an extensive number of spam emails. These emails are trying to lure users into the trap of clicking on links and providing credentials. Spam emails are somehow ending up in mailing box. This is interesting. It looks like the spam detector in place before being the merger has been disabled or damaged deliberately. Suspicion is on McGrady, who is not so happy with the merger. Problem statement. McGrady has been tasked with building a spam email detector using machine learning. She has been provided with a sample data set collected from different sources to train the machine learning model. So machine learning has so many applications in cybersecurity domain, and building spam detector is one of them. And in today's task, we will have some theory to read, which may get you boring, but bear with me. It's very interesting topic, and we have the task is divided into some steps so that it's easy to understand and absorb. Learning objectives. In this task, we will explore different steps in generic machine learning pipeline, machine learning classification and training models, how to split the data set into training and testing data, how to prepare the machine learning model, how to evaluate the model's effectiveness. Lab connections, these are some instructions to connect with the lab. All you have to do is press the green start machine button, that what we have already done. The lab will start on the right side in a split screen, which we are seeing right now, and it will take around 3 to 5 minutes to load. Overview of Jupyter Notebook. In this room, we will be using Jupyter Notebook as our lab because it's very easy to work on machine learning projects while we are working on each command. We are running each command uh, in front of us. So Jupyter Notebook is also covered in task 2. So I hope that you have already had some exposure on Jupyter Notebook. So it's important to recall that we will need to run the code from the cells using the run button. There are two ways to run the code present in the cells. So this is the layout of Jupyter Notebook. On the right side of the screen, it contains, this is the notebook and it contains the cells, and in cell we have the code. And on the left side, we have the files that we will be working on. So there are two ways. One, we can press the play button, or we can also have the shortcut Shift Enter to execute the commands. Okay, exploring machine learning pipeline. Machine learning pipeline refers to a series of steps involved in building and deploying machine learning model. These steps ensure that the data flows effectively from its raw form to predictions and insight. A typical pipeline would include collecting data from different sources in different forms, pre-processing it, and performing feature extraction from the data, splitting the data into testing and training data, and then applying machine learning model for predictions. And once it's done, we can then deploy it in a testing or deploy production environment. Okay, so it looks like the lab has almost started. So this is the Jupyter notebook, and we have three files: one the notebook itself, and the two data sets. One emails underscore dataset, and if we double click, we can see that it has two columns. Some This is something that we'll explore in a bit. Okay, so the zeroth step would be importing the required library. So what we are going to do, okay, first I'll click here so that we have some extra space. Okay, so the first thing will be importing the required libraries. Right now we need two libraries, one NumPy and Pandas. NumPy deals with the numeric computation in Python, and Pandas provide high-level data structure and the methods designed to make data analysis fast and easy in Python. So what I'll do, I'll press Shift Enter, and it will run those commands. So if there is a static, it means the command is still loading, it's taking time. But if when it's gone, it means that the commands within the cell has been executed successfully. So the first step would be data collection. Let's read it out. Data collection is a process of gathering raw data from various sources to be used for machine learning. This data can originate from various sources such as database, text files, APIs, online repositories, sensors, etc. And here we have a CSV file. What we'll do, we'll use this data set for our analysis, and let's load that. So we have the data, we need to import that, load that. So what I'll do, I'll press Shift Enter again, and the data has been loaded successfully in the variable data. So let's check the data out. I'll press the Shift Enter again, and the head command prints only the top five values. And if I want the last five values, I'll add tail data.tail to print that out. So the data set looks like it has two columns: classification and the message. Message contains email body, and classification spam or ham. So if a message or the email is spam, it will have the classification as spam, and so on. Okay. Data frames provide a structured tabular representation of the data that's intuitive and easy to read. Using the command below, we'll convert the data into data frame. Okay? It will make the data easy to analyze and manipulate. Let's run this command. This will convert the data set into data frame and print it out. It has converted now with this command, and it looks like we have a total of 4451 rows, which are records or emails, and two columns, which are classification and message. Let's move on to the next step. So in this task, we have divided the task into small steps so that it's easy for us to understand what we are doing actually. So the second step is data preprocessing. Let me read it out. Data preprocessing refers to the techniques used to convert raw data into clean, organized, understandable, and structured format suitable for machine learning. Given that the raw data is often messy, inconsistent, incomplete, preprocessing is an essential step to ensure that the data we are feeding into the machine learning model is relevant and of high quality. Here are some of the techniques used for preprocessing. So there are so many techniques that once we have the data, we need to clean it. For example, in case of emails, we need to first remove all the punctuations, all the comma, full stop, etc., and the words like and, or, is, this, that, because they do not add any value in machine learning understanding towards the classification of email being spam or ham, because they are common and they cannot make any impact or any difference. So we have to remove them, we have to remove empty values, etc. So this is the process of preprocessing. Feature extraction, we can extract the features, text pre-processing, tokenization. These are different ways we can apply in different situations. Feature engineering, creating new features or modifying existing ones to improve model performance. Utilizing count vectorizers. In this task, the pre-processing thing we will be using is count vectorizer, which can be used to convert text into numbers. Why? Because machine learning model understands numbers, not text. This means that the text needs to be transformed into numeric format. Count vectorizer is a class provided by sklearn library in Python. It achieves we achieve this by converting the text into token words count matrix. It is used to prepare the data for the machine learning models to use and predict decisions on. Okay, so it will be more clear when we get execute these commands and understand the output. So what I'll do, I'll execute these commands and then break it down for you. Okay, so what we are going to do first, we are going to import count vectorizer from sklearn and then assigning it to a variable vectorizer. And then what we are going to do, the data frame which contains df that we had defined earlier, which contains the column message, we are going to transform using the fit underscore transform function to transform into numeric values. So message is has the text, and now if we execute this, it will be saved in the variable x, and let's print it out and see the output. Okay, this is the output, which looks kind of confusing, but let me explain. We have the email at zeroth index. In the email at zeroth index, the word at the index 6653 has occurred once. Similarly, in the email document or email zeroth index, the word in the index 6733 has occurred 3 times. So it is calculating the count of the number of occurrence of any word. For example, in spam, the word congratulations may have occurred 6 times. So it would increase the probability. So what this has done, it has converted our email into numeric matrix so that we can perform machine learning predictions and model on. We can train on this data set now. So now we have the data set in numeric representation. That's very interesting and very important topic, very important step. The third step. So the third step is, now that we have the data set of 4451, I guess, numeric matrices, what we need to do in the next step, we need to divide that data set into two parts. Why? Because we want to train our model on one subset and then test our model on the second subset. It's important to test the model's performance on unseen data. By splitting the data, we can train our model on one subset and test its performance on another. This is a very clear explanation or image. Like, we have the data set, we are going to split that into two parts. So what we are going to do, these are the commands. Let me again run this command and then I'll break it down one by one. So what we are going to do, we are going to first import the function train underscore test split. I'll press shift enter, and then what I'm going to do, there are two variables. Capital X contains the numeric representation of the dataset or the email body, and now Y contains the data frame of classification, spam or ham. So, and we are going to use this, and we will be providing three variables. Capital X, the numeric representation of email body, Y, the classification data set, data frame, and third, the test size that we have set for 20% or 0.20. So what it will do, it will split randomly 20% of the data set uh, for testing purpose, and the remaining will be something that we will use, and the variables are x underscore train and y underscore train. These are the two variables we will be training our model on. And when we are going to test, we will use x test and y test. And this has been explained here as well. So x train, the subset for the features to be used for training, y train, the corresponding labels for x train set, and similarly for others too as well. Now we have split it over. Let me run this. So we have successfully splitted our data into two parts, and the variables, the results are stored here. Next step is like this is the next step. So we are moving one step at a time. Model training. Now that we have the data set ready, the next step would be to choose the text classification model and use it to train on the given data set. Some commonly used text classification models are explained below. Naïve Bayes classification, SVM, logistic regression, decision trees. These are all the classification models that are used to train on the text-based data set. And in this task, we will be using Naïve Bayes. So let's dive in straight to the Naïve Bayes. Naïve Bayes is a statistical method that uses the probability of certain words appearing in spam and in ham emails to determine whether a new email is spam or not. Let's break it down how this actually works. So how Naïve Bayes classification works. Let's say we have a bunch of emails, some labeled as spam and some as ham, just like this data set. The Naïve Bayes algorithm learns from these emails. It looks at the words in each email and calculates how frequently each word appears in spam or ham emails. For instance, words like free, win, offer, lottery may appear more in spam emails. So if we take a look at this data set, we can see that, for example, in spam, there is a word award. Maybe award is used frequently in multiple spam, so it will remember that. The Naïve Bayes algorithm calculates the probability of the emails being spam based on the words it contains. When a model is trained with Naïve Bayes and gets a new email that says, for example, win a free toy now, then it thinks this is where it's training itself. Win often appears in spam, so this increases the chance of email being spam. Free is also very common in spam, further increases the spam probability. Toy may be neutral, often appearing in both spam and ham. After considering all the words, it calculates the overall probability of the email being spam or ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies the email as spam, otherwise it's classified as ham. Okay, let's use Naïve Bayes to train the model as explained below. So this is how Naïve Bayes works. Let's execute these commands and then I'll break down step by step. So in the next step, what we are going to do, we are going to import multi-nominal MB, which is the function in sklearn.naivebase library. So what we are going to do, we are going to import this and then assigning it to the variable classification. So CLF would remember or would be used as Naïve Bayes model. It will be used to train. And in the next step, if you look at we are trying to use this to fit or train on these two variables which contain the numeric representation of the email body and the classification of either spam or ham. So what it's doing, it's working on looking at this data set and trying to remember the numeric representation of this data set and trying to remember what words, what's the frequency of which word and which word were more frequent in spam, so that it remembers what's next. So okay, let me execute this. It, it's trying to remember based on what we are producing, what we are giving it as an input. Next step would be the fifth step, model evaluation. So in model evaluation, we will evaluate if our model has predicted correctly. So what we are going to do, we are going to provide it the test data set. So after training, it's essential to evaluate the model's performance on the test set to check its predictive power. This will give you the metrics such as accuracy, precision, and recall. Let me execute these commands, and then we'll look at the output and we'll try to break it down one by one. So I'll execute these commands, shift enter. Okay, so let me break it down. We are importing classification underscore report from sklearn's metrics, and then we are providing our classification with to asking it to predict on x underscore test dataset, which is the dataset that we had separated before. And then we are printing the classification report on y test and y predict. So what it has predicted, and we are printing that out. So this is the output. Let me understand, read it out. So it says that for ham, the model predicts it's not a spam. It's correct 99% of the time. For the spam, if the model says that it's spam, the model is correct 90% of the time. Similarly, for the ham, for the recall, the model captures 99% of non spam or ham messages, and similarly for the spam, it captures 96% of actual spam. F1 is the balance score between these two, of these two. Sport is like we have 789 ham messages in the test data set and 102 total spam messages in the test data set, and these are the averages. Okay, so this is the output, means we have tried to predict our model, predict on the test data set. What we have done, we have first trained our model, which is saved on CLF classification, and it remembers. Then it tries to predict on the test data set that we have provided next. So each one is explained below. Okay, so now it's time to test our model. We have uh, we have evaluated. It's time to test our model. So how we are going to do? We are going to provide it with some random email text that we think that it may be a spam or ham. We need to test. First, we will need to transform the message, and then provide that message to our classifier. And then we'll see, let's print out if the message, what's the prediction. So what's next? Step number 6. Okay, I'll press shift enter, and it says it's a spam. Why? Because it's looking at it. It says that today's offer, claim your this and that. So it has calculated based on the probability of the words like offer, claim, worth, discount, vouchers, etc., which appear more often in spam than in normal messages. There's a chance of false positive, but let's leave that out for now. Okay, so that's it. That's our task. And what's next? MaxKitty is happy that workable spam detector model has been developed. She has provided us with some test emails in the file testemails.csv and wants us to run the prepared model against these emails to test our model results. So we have, if look, we have a test emails file which is only messages. Okay, so we are going to. It says that update the following code to include the test email files and run the trained model against these emails. So what we are going to do, we are going to add the test test emails dot csv, and okay, the test file has been loaded, and we need to change this as well. It would be test underscore data, because that's the variable where we are loading this CSV file. So let's load this and print the top five values. So this is, we only have the messages which contains email body. Okay. We are going to transform our messages and into numeric and metrics, and then we will apply the prediction. So what we are going to do, we are using the vectorizer to transform the test data and the column messages, and then applying the prediction, asking our trained model to predict on this data set. So let's run this and let's try our result out. Excellent. So what we have done, what we have got the prediction on those messages, those email bot. So this is the message, and this is the spam, and excellent. So we have gone. Okay, so that's it. We have got the result. Now it's time for the conclusion. That's it from the task, and from the practical point of view, we have to consider the following points to ensure the effectiveness and reliability of the model. There are so many things to do. Some of them are mentioned here, like continuously monitor the model's performance on a test data or in a real environment, collect feedback from users and regarding false positives, use this feedback to ensure the model's weaknesses and the areas to improve, deploy the model into production. So there are a couple of steps that we need to do on what's next. And next, after we have predicted the model and prepared it, and next time is to deploy it in the production. Excellent. So let's solve this. So what is the key first step in the machine learning pipeline? That should be very simple. It's data collection. Submit. Okay, which data pre-processing feature is used to create new features or modify existing one to improve the model's performance? So let's scroll up, and these are the model classifications. And I think if we read them out, it's feature engineering because it's used to create new features or modify existing ones to improve model performance. So this should be the second answer. Excellent. During the splitting step, 20% of the data set was split for testing. What is the percentage weightage average for precision of spam detection? So let's find out with the weightage average. That's 0.98. 0.98. Yeah. So next question is, how many of the test emails are marked as spam? I think it's two or three, if I'm not wrong. It's okay. It's one, two, three, and one of the emails that is detected as spam contains a secret code. What's the code? So these are the two spam emails. Let's look at this, and one of the emails should contain the flag secret code. Okay, this is the secret code. Um, it says I hate best festival. Let's change. I hate best. Excellent. So that's it. If you enjoyed this room, please check out other phishing modules as well. Complete. So we have completed the task. Congratulations. And just as a final, this is not it. What we need to do, we need to improve our model's performance. How we can do? There are a couple of steps. We can change the percentage of the test data from 20% to, let's say, 30% to see how our prediction model works. Or we can also increase the size of the data set, because we are in a testing environment. We can use limited data set, but the more size of the data set will have, there is a more chance of less false positives, let's say. Okay, so I hope you enjoyed this little task, and see you around. Thank you so much.